Okay, today is day 2 for section 6, the final section of chapter 7. And day 1, yesterday, we were solving systems of linear inequalities. So we had those shaded regions, looking for the common shaded region. Okay, so now today, we will write the inequalities that go with a system that they just give us. They're going to give us a picture of a inequality system, and we need to write the inequalities. So before we write the steps, we're going to go practice one. So leave yourself about 4 lines so we can write the steps, and let's go practice one. Here it is. Okay, can you see I blew it up a little bit? We have a shaded region up here, right? And we see the boundary lines that have formed this, okay? So how can we write these inequalities? I mean, let's just start with one of them, right? We'll start with one. Which one do you want to start with? Who wants to start with the dashed one? Who wants to start with a solid one? More people want to start with the solid one, okay? And what is interesting about the solid line? It's called a special case. It's a vertical line, right? So if we were not looking at it as an inequality yet, if we're just looking at it as a line, we have to remember how to write the equation for a vertical line, right? And you got that, right? You got that? We've talked about some of these special cases this week. So where is this line? It's either a y equals something or an x equals something, right? And so what is it? Tell me what it is, Bella. X. So she's saying if you were just going to write the equation for this line, it would be x equals what?
X is, well, I don't really know the sign.
We don't know the sign.
But it's a line.
Okay, let me just do it this way. Let's just write it as an equation. Just look at the line right now, and then we'll do the inequality after. X equals what? 3. Does everyone agree? That line says x equals 3. Okay, but as she was just pointing out, this is not just a line, this is an inequality. So she said there would have to be an equal sign under some inequality sign. Why is there an equal sign under it? Because it's a solid. We're looking at this and it's solid. So we know it has an equal sign. We are trying to figure out whether it should be a less than or a greater than sign above. So we're going to just kind of leave an open space here. And how can we determine what it is? What do we do, Dylan? So what is he really doing when he says this? He's testing a point, which is what we do with inequalities, right? Shh, girls. We're going to test a point. He wants to test 0, 0. Now look at this. Is 0, 0 really, is it a solution of this system? It is. So it should work in this inequality. It should make the statement true. So let's plug in 0 here. 0 is what to 3? What is 0 to 3? Is it greater than 3 or less than 3?
Less than.
It's less than 3. So this is what should be true. It should be true. We're making a statement that should be true. So now how do we complete the inequality? What do we do, Tessa? We just put in the sign, right? Here's one of the inequalities. Okay? So we wrote the inequality as though it was just we looked at the line and wrote it as though it was just a line. And then we tested a point to figure out which inequality sign should be where the equal sign is. Okay? Now let's do the other line, which is not solid. It's dashed, right? It's a dashed one. And so how can we write?
Isn't that -3 though? Because it's on the left side. So
This, where is 0? Isn't this 0,
It's
0?
not right, yeah, that's 0.
This is 0, 0, so here's 3, positive 3. So that's fine. Okay, so looking at this second line, how do you want to write the equation? I mean, it's kind of a regular type of line, right? It's not a special case. So what's our favorite model for linear equations? Everyone? Equals, let me do it in a different color. Y equals mx plus b. We could use slope-intercept form here. And can you identify the slope and the y-intercept? So Mary, what's the y-intercept?
It's -1.
So she sees it right here. So it's -1. And the slope?
It's,
Let's imagine going up here and over here.
it's up to over 3 or 4.
Up to over 3. So we simply fill in the slope and the y-intercept. But this is not an equation. This is an inequality. So we got to deal with that. This would be the equation if it was simply a line, but it's an inequality. So let's leave a blank space where the equal sign is. Okay? Leave it blank, and we're going to figure out what inequality sign should be there. Okay? And just as we did on the last one, we're going to have to test a point, right? And so what point is true for this dashed line? It is. Our favorite test point, again, should make this statement true. Okay? So we're going to come over here. I'm trying to save room. We're going to plug in 0, 0. 0 is what? The 2/3 times 0 minus 1. What is 0 is, well, good job. So 2/3 times 0 is what? 0 minus 1. So 0 is what to -1? Greater than. So we come back to our equation, and now we can write it as an inequality. Do we need to put an equal sign under that? Why not?
Because it's dashed.
Good job, it's a dashed line. So there are the two inequalities. Okay, so we now will go back to your rule box and note how we did this, right? So when we looked at this graph, and you're told to write the inequalities, did we start with just writing inequalities? What did we write first? Equations, right. So we write an equation for each line, and then we convert it to an inequality. Actually, I should have probably put this in 3 steps. Write an equation for the line, and then test a point to write the inequality, right? And then finally, don't forget dash solid. I'll tell you what it is. Okay, let's try this one more time. We're going to write the system of inequalities for this graph. Okay, so this actually is challenging in its own way, but is just packed full of what? Special cases. That's what this is. Special cases, huh? So which line would you like to write the inequality for first? Liam. The dash one. So he's going to write this one first. So tell me what the equation would be if it was simply a line. He says it would be x equals 2. Thumbs up if you agree. Good. So he got it right. X equals 2. But now, what do we do, Liam? And so 0, 0 should make this statement true. So he's going to test 0, 0. And 0 is what to 2? 0 is less than 2. So we go back and write the inequality and tell us what it is. X is less than 2. Now, should there be an equal sign under there? Why not?
Dash.
It's a dashed line. Good. So we have it. X is less than 2. And the second line is solid. Sophia, zoom up.
So you would divide to the next and
She says y equals mx plus b. Okay? I mean, I suppose you could. What is the slope? The slope is 0. And what is the y-intercept? 4. So what? Now tell me what this equation is when we simplify it. So y just equals 4 because, yeah, this is a special case. Okay? So some of you probably didn't go through using slope-intercept form, right? You just went straight to y equals something. And is 0, 0 something that should work in this line? Should it be shading toward that point? Yes. So we're going to substitute just the y part, right? Because that's all we have. So how does 0 relate to 4?
Less than or equal to.
0 is less than 4. And I hear Lindsay saying equal to because this is a solid line. So she wants to put it right in right now, which is fine. And so we go back and now write the inequality, Sophia. There it is. There it is. Good. We got both. Okay. Hannah just asked if 0, 0 is not a solution, could you still use it as a test point? And you could, right? Let's say that it wasn't a solution. Let's say it was shaded over here or something like that. And we just plugged in, or let's say it was shaded above the line for the second one, okay? So say there was a common area somewhere up here. 0, 0 would not be a solution. You could use it, but it should make the statement false, right? So you would have to make sure that how does 0 compare to 4? 0 is less than 4, so you would have to take the opposite sign. 0 is greater than that, okay? So when you use a test point that is not a solution, it must make your statement false. I don't think most of you will do that, but it's possible to do that, okay? Tessa? This is day 2's assignment.